So I work to present the ongoing project Inside School. Well, briefly, this project consists to allow students, middle or high school, to access to the data from the space mission Inside. So I want, with this presentation, to highlight what we have done to share data from the science team to the schools. Okay, for all of you who are not familiar with this space mission, InSight is a NASA mission where the CNES or IPGP in particular are involved already. This mission consists to, oops, I cannot, okay. This mission consists of a deployment of Mars of geological station with specific sensor to explore the internal structure of a red planet. The mission arrived in November 2008. Arrived in November 2018 and was launched in May, so 6 months before. The lander has deployed the sensor, including a seismometer that we call SAIS, to monitor the Mars seismic activity. And for now, 1 Martian year, that's been 2 years for us, we have been receiving data from these sensors: ground motion, winds, pressure, temperature, so a lot of data. And this data are very interesting for the science, of course, and for schools, because since the beginning of the project, an educational chapter has been planned and organized with the support of the French National Education Ministry. With Insight, you can understand that it's a great opportunity for to offer students, young students or old students, new activities to learn more and better about the planets, their structure, their environment, with a focus on Mars, a neighboring telluric planet we share in common but not similar history with the Earth. So with this plan, with this education plan, we have so many opportunities, but also a lot of challenges. So opportunities, of course, because you can propose to follow the seismic activity on Mars, to study a telluric planet in a concrete way, or to use the mission to experimentally test hypotheses in the classroom, or also to use to ensure teacher training on the tools and new approach inspired by this mission. Clearly, you can be tuned into Mars with this mission, of course, but it's also a lot of challenges to organize this education plan, because how to propose scientific data for teaching is not so easy. How to propose a wide variety of educational approaches, and also how to support a teacher. So in fact, Inside Education Chapter has been entrusted to Geoazur lab, which is a lab from University of Côte d'Azur, because this lab has been running the French educational seismological network for many years, and which maintains links with a lot of other network in the world. So that means that the education plan was run quickly because with this expertise. In fact, at the beginning of this plan, we had to define which kind of resource we will share with the teacher. So we choose activities topic, as you can see on this slide. So we have a topic data, so you can understand is what's mean teaching with real data to explore the planet, or the topic telluric. telluric means that you implement experiment, hands-on activity in geophysics, in planetology, in meteorology. The topic journey, because it's clear that we have to understand all the journey from the takeoff until the landing on Mars. We have also a big topic about the sensors, because if you use data and real data, you have also to understand the problem linked with the sensor. And the final one is the topic signal, because all the data are transmitted from Mars to the Earth, and you have to understand how this data and how this transmission is running. But for today, for this presentation, I think I want to focus on the topic data, which seems to me the most relevant today for this presentation. So let's go to the data and to see how we display data at school. Access to the data and use the data at school is not so easy. So we have made this website, as you can see, and I'm going maybe to go through this website to show you some aspect of how we share the data with the school. So the website is here. I don't know if you can see the website. Yes, can you see the website now?
Yes. Yes.
Yes, okay. So you have the entrance of the data, as you can see, and you have some tab like this. So the first time for the schools is to be able to what we call Mars replay. So you can see directly what we call the sol plot. So that means it's the ground motion for one day. So you are directly on Mars. You are on the Martian time. So each line is 1 hour on Mars. And you can see the ground motion directly recorded by the seismometer on Mars. So the school is quite amazing to access to this kind of data. Of course, you cannot make a lot of science with this, but you have directly a picture of the ground motion. And you can see that during a day on Mars, the seismic noise is not the same in the morning, in the end of the morning, and in the afternoon. It's because the wind in particular. And you can also access to the weather data. So I can ask for some weeks of data like this, and you have directly diagram where you can see the pressure, the temperature, the winds, day by day, week by week, and you can make a lot of comparison, analyze with this kind of data. It's more pictures, of course, but oops. It's interesting because directly you have some element to see, but and very oftenly we have also to provide software who will give the access to the data, because the data are not so easy to analyze. So this is our a tool that we have made for this InSight mission. So you can see Mars, of course. And of course, you can ask here, event of size, you can ask for some seismic event recorded by the seismometer and validated by the science team. So if I look at the seismic event occurred during the Sol is the Martian day, so the Sol 235, like this, you have access to the seismogram, but you have not access to a picture. You have also access to some tools who can help you to make some calculation. For example, if I am student at school, I can look the origin time. So that means this is the origin time produced by the science team. So that means that I have my the first arrival, seismic arrival, the P waves and S waves. So I can also ask for the arrival time validated by the science team. So this is the P waves and S wave, and I can make some calculation because you see that I have a tool.
Excuse me to interrupt you. Actually, we see the image of the website on your slide, but not your not your
yes.
internet connection.
Okay, so
because you had a lot of things on your slide that I thought it was the website, but
and how can I do this?
So
I will just do again.
Yeah.
Okay.
Yes, it's working.
Okay. So this is Mars. Okay, sorry. This is I have selected a seismic event. So I have only four seismic event because this is only four seismic event validated by the science team. So I have asked for origin time, the seismic waves arrival time. And so a student can pick the P waves and S wave. For example, here I can determine the delay between the P and the S wave. And I know, because I am a student who at school, but I can use a timetable to appreciate, to evaluate the distance. So in that case, I will find something like 1,500 kilometers because the delay between P and S is 150. So that means that this seismic event is somewhere around Inside Lander with 1,500. So I have also some tools like to make the circle. And so if I do a circle with 1,500, I have the seismic event is somewhere along this circle. So the student can already know something about this seismic event, and it can compare, because it's very difficult to determine the azimuth of a solution. So it can ask also for the catalog of Marsquake. So this is the Marsquake recorded and validated by the science team. And the student can look at his work and see that maybe the seismic event that is going analyzed is maybe the Marsquake number 3 that we can see because this Marsquake number 3 is on the circle. So you see, we provide data. The data are validated by the science team for the student, and the student can work with the data already filtered, already worked by the science team to make this data more easy to use for the student, even if we are at school, at middle school. So this is one example of what we can do like this. So if I go back, I have maybe to go back to here. Yes, can see my PowerPoint too now.
Yes.
Yeah. So it was for the data. Of course, we have other topic because all the mission, there is so many resources that we can also explore the telluric topic. So that means make a lot of hands-on activities, for example, about the crater impact, as you can see here. But I go quickly because it was more about the data that I was to focus my presentation. It was also about the journey. So of course, how do you get to Mars? So we can use movies, we can use some diagram to explain the date of a takeoff, the date of a landing, and things like that. We also develop a lot of sensors. So what we can see on this slide is a kit of sensor, is what we call the Inside Seismo Kit. So we provide sensors like accelerometer, but also piezoelectric cell or barometer, luxmeter, thermometer, to make this sensor can be made by yourself, because it's only Arduino card and sensor. So it's a very low cost sensor. And we develop also the software that we call RISC. And this software record all the data coming from this sensor. So the student can make a lot of hands-on activity directly on the classroom with sensor and understand what a sensor is. And it's important when you will work with real data after. And the topic signal, sometimes we use a lot of the example of a signal between the moon and the earth with the laser, because we are it's very important. So in fact, what I have shown just before is, when you want to provide data to school from scientific data, from a space mission, well, you have to first to provide a database with a web server. It's what you have seen with the tools and also with a sensor. So you need data, but also you need a tools lab. A tools lab because you have to develop software, because education expect data with a special format, with an easy use, with a low cost material. Everything must be downloadable. Everything must be free. So that means that a team work directly to provide this data and this software. But in fact, it's just one step of the plan. The other step is to help the teacher to teach with real data. And it's a real challenge. So we had to organize, and we have organized 2 teacher workshops in January 19 and March 20 to welcome teacher, not only French one, but also from other countries, Greece, Spain, Portugal, Italy, in Great Britain, to explain and to propose the tools, to propose the data, and to make the case study that the teacher can make coming back at school. And I will also focus now just some slide about the next step is the step of a student, because there are the data, there are the kit with the sensor, we have a teacher, but you can also access directly to the student. And for this, we propose to the student what we call a contest, the Namazu Contest. So it's a challenge, a playful challenge for schools, where we propose to the student to explore the mission, to be directly linked with the science team. So they have a mentor, so people from the Inside Science team, and they play with the data. And one of the big things that we have done, it's something that it's important to show and to know. For example, it was what we call the blind test. So the science team has done a blind test, 12 months with 12-month data. It was not a real data because it was before landing on Mars. So it was a synthetic data, but realistic estimate of data, estimation of background seismic noise. So the student wanted to participate to the blind test. So something like 14, 15 schools participated officially to the blind test at the same time that other science lab, and they play to look at the data and try to locate, to determine the event and to locate event if they can. And so as you can see in the diagram here, just below, the school network determined a lot of events. Most of them were wrong, of course, but they succeed to determine some correct detection. So that means that the work was very interesting, because the students were very involved to use the tools to try to find the event and to participate with the science team at this general effort to understand if they are able to look at the real data when this real data will arrive. To conclude now, actually, I show you the visit of a website, the website where you can find the data, where you can find the tools, and you can see that it is a website for education. When there is holidays, the visitors are not very numerous. When there is an event like the landing on Mars or teacher workshop or the data release, well, the visitors are very more important. And sometimes, and what we have done for the first lockdown with the COVID pandemic, is to make the insight at home. So daily, the student has a question to resolve. And we have seen that there were a lot of people connected. So it was a daily contest, very interesting, because people were very involved to participate to this. So that means that when you speak about education, data is are very nice, but we have to provide a lot of things around the data to give this data more useful, more amazing for the student. And that means that it's necessary to make an animation of a network. And so you need workshop, newsletter, school time, and respect also the school time. And this experiment is successful enough for us to imagine, and it is the coming soon operation. It will be Mars 2020. You know that Perseverance robot is going actually to Mars and to land in next February. And we will, with the same team, or the team from Inside Education, to propose to the schools now another space mission with data. So we will run with a lot of Martian mission. And I think it will be interesting for the teacher, because in this topic, and it was one of the first presentation in the afternoon, you can join people from physics and from geoscience. So what we call in France, physics and SVT teacher, and making science together. It's very important also to use planetology, and planetology offer to the teacher a new way to work together, sharing the data together. Thank you. That's all for today.
Thank you very much, Jean-Luc. So yes, it's a very complete full plan for data using at school. It is very it's a very well advanced project. It's impressive. So is there some questions or comments?
Let's go. The first question. So I am with Insight behind me. You have seen, yes?
Perhaps I can start to ask you a question. Do you allow people to connect by themselves to the website and use the data, or do they have to to be in contact with you and follow the school, the workshop, etc.?
Yeah, of course, twice. So that means that everybody can go to the website, download the data, look at the data, and play with the data. But of course, when we propose something like a contest, or when we provide a kit of sensor, we provide kit of sensor for schools. So we work with a network, what we call the network of Insight. So we have 100 schools connected with Insight at School. And so they can ask for us from help, tools, case studies. And it's also back because the school propose hands-on activities. So one teacher say, okay, I have done this in my school. It works very well. So we integrate the hands-on on the website. So the website is not only a production of one people, but a network. But of course, sometimes we don't know some schools who work with Insight, but they are not in the official network. Yeah.
Okay. And did you change something in the way you're providing the data with the new French program, for example? You know that they include now some Python learning school and lessons.
Yeah. If I well understood, there is a part of Insight where, with a sensor, for example, we provide tools. Well, the entrance of a numeric field, so student can explore to make some program in Python to work the robot or the sensor. So this is a way to enter in the Insight. So you have people who come with Insight at School for seismology, but not a lot, because seismology is not some people are not so interesting in seismology, but they are more interested about Mars or about the atmosphere. We have a lot of data with the weather, so people are interested with the weather, and the weather will be compared with Perseverance, because Perseverance we landed in other place. So in February we will have an atmospheric weather network on Mars. And so people are more interested by this, and some people are interested by the technological aspect of a sensor, and so they come to Insight for that reason.
Okay, thank you.
You're welcome.
We have a comment from Laure Fallou. So Laure, do you want to ask your question, or do you want me to read?
What do you want, Laure? What do you want?
Sorry, I can ask my own question. I may have missed information. I'm sorry if I did, but I was wondering if you collect feedbacks from people and from teachers, and I actually was writing another question about the types of school that are taking part in the project.
Yeah.
Like, do you also have schools in less what do we say, economical rich areas of the countries?
Okay. For the first part, for the feedback, it's always easy to get feedback from a teacher. For the student, it's more difficult because students don't stay a lot of time at school, and when we want to make a feedback for the old student, it's difficult to know how to contact them. Yes, and there is for the teacher, it's easy to have a feedback, but I can tell you, and you can understand this, that to make a real form, and it's a special job. So sometimes we produce some survey, but the questions are not good enough. So we need to make some survey with more professional aspect to get more information about what is doing well or not. But we have done one about the French seismological network a few months ago, and it works very well about the 25 years of seismology in France, about school seismology. And the other aspect is main of the school are middle school, because in middle school teacher seems to have more freedom to organize a project. Actually, high school is a little bit difficult because everybody is looking at the cursus, but inside seismology on Mars can be included in the cursus of the high school. We have some school in some school, but not a lot from a professional aspect, but more for the seismology and more about the building, how to build the houses, and what seismology can bring to them for this, but not a lot, unfortunately, not a lot.
Thank you.
Okay. Well, thank you again, Jean-Luc. If there is no other question, then we will make a small break, a 5-minute break.
Okay.
Sorry, there is a question, sorry, from Asma Stenhauser. Asma, do you want to ask your question?
I can see the question on the chat.
Thank you.
Yeah. So I know Astro à l'école from Sciences à l'école, of course. Some school, in fact, we have not included Inside School in Astro à l'école because IPGP asked directly to Geoazur Education to organize Inside Education about seismology. But in the network of the schools, there is several schools who participate to Inside School, and they are already involved in Astro à l'école. So there is a link, but not an official link. Yes.